Hi everybody, I'm Maxime. I'm a senior developer advocate at MongoDB and I'm based in France. And today I want to talk to you about MongoDB with Java, client-side field level encryption in a production environment with Spring Boot and Spring Data. So buckle up because it's going to be a very nice video and we're going to see a lot of things about how to configure CSFLE with Spring Data. This video is based on this blog post that I wrote a few days ago. And so if you don't know about CSFLE and Spring in general, I suggest that you look at all the links available here, especially this one here, where you have an extra video I recorded a few days ago that talks about CSFLE with the Java driver. You have a way easier example with just the basics of CSFLE, and I talk about what is CSFLE, how it works, and all the details. I don't want to cover this again in this video, so please check this video first if you don't know enough about CSFLE, and same from Spring Data. If you don't know Spring Data and Spring Boot, I suggest you have a look first to those links and come back to this video. First of all the code that I'm going to discuss today is available here, so you can clone the code and this repository from this place here in the MongoDB developer organization in GitHub. And yeah, let's get started and let's talk about how to configure CSFLE with Spring Data MongoDB. So in this blog post, there is this schema where I try to explain all the pieces we need to get CSFLE up and running with Spring Boot, Spring Data, and yeah, in general. So let's cover this quickly and have a look to how it works, and so we can map then this schema to what we have in the code. So first we see here on the right some basic configuration, and you can notice that I need a temporary standard Mongo client just to create the key vault collection and the unique index on the field key alt names that we need for the vault collection. So this, of course, you need to do it only once. So it's not mandatory to keep it in the code, especially if you create this manually with a couple of command lines in MongoDB. So it's your choice. You can also remove them from the code. I don't really mind. But it may be useful if you have some CI/CD environment that is, running some integrated test, for example, with a brand new cluster, MongoDB cluster. So it might be useful to keep this in the code. So the vault is automatically recreated every time you need a new one. But in theory, in a real production environment, you create the vault only once and the index only once. So it's really up to you. Then we can create the Mongo Key Vault client, which is called Mongo Encryption in Java. We have the Key Vault and we have this client. We can then create the data encryption keys. To create those keys, we need the name of the collections and how many collections we are actually encrypting in our MongoDB project. Once we have the keys, we can create the schemas. So all this part here with the entity classes. So for me, in my example, is going to be a person and a company entity that I store in MongoDB. Those entities, because we use Spring Data, we have a schema. So that's the schema we have in the code already. I'm reusing this schema to generate the dynamic JSON schema, to generate dynamically the JSON schemas that I need to configure the MongoDB automatic encryption client, the one that we use to connect to MongoDB, read and write documents automatically with CSFLE. So this client will be CSFLE enabled, if you like. It's going to be able, of course, to use the master key from my local KMS. Local KMS here because I'm in a tutorial, but if you're in a production environment, I recommend to use some other solution from AWS, GCP, or Azure. That's going to be way more safe and secure than my local KMS here. This client will also be able to use the automatic encryption shared library. This is the automatic encryption shared library. It came in MongoDB 7.0. It's related to queryable encryption, which we're not using in this project here, but it's a replacement for MongoCryptD, right? So I'm going to come back to this schema in a second, but just so you know, MongoCryptD has now a new version, if you like, a new replacement, and the recommended version now it's to use this automatic encryption shared library. So our client is configured with all this. The automated encryption shared library uses those dynamically created JSON schemas with data encryption keys that has been also automatically generated. Everything is configured, and this client in the end knows about all this and can manipulate our MongoDB documents, read and write, completely transparently for us. When all this is done and configured, we can finally create our encrypted collections, which will also support a JSON schema on the server side, so on the MongoDB cluster directly. So we have also some double check done on the server side, on the MongoDB side, where we store the documents. So we can verify that the final documents that land in MongoDB and are stored in MongoDB are not accidentally written in clear text, for example. It's useful, especially if you have several people working on the same MongoDB instance with maybe several different clients, maybe one in Java, one in Python, and you want to make sure that the configuration on both, backend system is done correctly and the encryption is done properly with all the clients. So in this solution here, in this example, I'm using the JSON schema that we generate actually twice. I'm using it for the automatic encryption and decryption of the documents, but I'm also using it for the backend in the MongoDB cluster directly for double check. So there is a client side use of the JSON schema, which is on the driver side, and there is a use on the backend side on the MongoDB cluster. All right. So this project is a Spring Boot project, very basic, using Spring Data. So I'm using the very standard controllers, services, and repositories with private entities. So for me, person and companies, and I'm exposing public DTOs to the final requesters, right? So for me, it's just a one-to-one mapping, but in a real project, it can be different. Just as a reminder, that's how we do a write operation in MongoDB using CSFLE. So we are using the automatic encryption configuration, the JSON schemas, to check in the automatic encryption shared library what needs to be encrypted or not. Right? Yeah, it's here. Once this is validated, we can generate the encryption commands. We can fetch the data encryption keys in the key vault, decrypt those encrypted data encryption keys using the customer master keys stored in the key management system. And with all this, we can finally encrypt our fields and send the document to MongoDB, where the double check is happening using the JSON schema I talked about a few minutes ago. And the read, it's basically the opposite. I don't need to explain, I think, but same thing is happening. We read the fields from the query. If they need to be sent encrypted to MongoDB, we encrypt them using, again, the automatic encryption system. We access the keys, data encryption keys, we decrypt them, etc., etc. And finally, we retrieve the document from MongoDB, and we decrypt automatically the fields using the data encryption keys before sending the final version of the document back to the client in clear text. But remember that with CSFLE, everything past the driver is completely encrypted and cannot be decrypted unless you have access to both the data encryption keys and the master keys. All right, so let's have a look now directly to the code and jump in the most basic part. So let's start with the basics. So again, the basics for me is HTTP request. So let's start with the controllers, services, and repositories, right? Just to show you that it's actually in the backend, it's a normal project, right? It's a normal Spring Data and Spring Boot project. So here you can see that we have a controller, person controller, for example, right? So person controller, I have @rest controller. Maybe I can zoom a little. We have the @REST controller annotation. We have the creation of the person controller with a service. And we have a mapping, so get persons to get all the persons. We have post a person to create a person. And we have get person SSN to find a person by his SSN. This is possible because it's completely configured for me, so I don't need to do anything else, as you can see here. Even if SSN here is an encrypted field, right? I don't have anything special, any mention of CSFLE, any manual encryption or anything. Everything is fully automated for me. And at the end, I have some exception handling. So this one is for the 404 error if I don't find my, my person. And this one is for any other type of internal server error. Let's see our model, right? So here we have the person entity. And we can see the JSON schema I was mentioning before, right? Well, the schema here of our person document, which we can reuse to generate those JSON schema. So we have the @document persons, which is going to be the name of our collection. We have here the @encrypted key ID, which is going to be replaced by the key ID, so the key ID of the data encryption key that we use to encrypt all the documents in our persons collection. Here in our person entity, we have a few fields, so ID, first name, last name, SSN, and blood type. As you can see here, only SSN and blood type are encrypted, SSN with a deterministic algorithm, and blood type with a random algorithm. Because I'm using a deterministic algorithm for the social security number, that's why I can do here this request here and find a person by SSN, even if it's encrypted, because it's a deterministic algorithm. I can query by SSN. I would not be able to do that by blood type, for example, because I'm using the random algorithm. Okay, so now we can visit the service, which is just an interface, which implements the 3 methods. I can check now the implementation in the person service implementation, which is using the person repository. Here you can see the implementation of the 3 methods, nothing special. The only thing to note is that I'm exposing person DTOs to my controller, and I'm sending entities down to my I'm just requesting my entities from my repository, but yeah, the repository works with entities. So here you see the find all, you see the save, where I just save the person, and yeah, it's basically just a pass-through. Okay, so let's now see the repository, person repository here. So the repository, very basic, it's fully automated and implemented by Spring Data. That's the magic of Spring Data here. So you just create the repository @repository annotation, and you create the person repository interface with the Mongo repository person entity. And here, so the default here, find all and save came from the Mongo repository, but the find first by SSN, I need to create this manually here, and it's fully automatically implemented by Spring Data again. So that's very nice. Okay, so as you can see here, it's exactly the same thing for company, so I'm not going to show you the exact same thing with company, but it's exactly the same thing. And as you can see, it's very basic. Here, there is no mention of CSFLE, nothing about encryption. The only mention you found here is in the model, right? That's the only 3 things I have to mention. All I have to say is it's encrypted with this key, it's encrypted with this algorithm and this algorithm. That's it. Here, I'm just gonna mention that this is actually not the key ID. It's gonna be actually generated when the data encryption key is created, and this is a spell expression. that is going to be replaced at the time I generate the JSON schema. I will show you this actually, why not right now? So here you have this class here that is mandatory to interpret this. So it's called the Entity Spell Evaluation Extension. Unzoom a little. So it implements this evaluation context extension. And so all you need to do here is implement this get extension ID, which is Mongo crypt. Okay. If I'm not mistaken, this is just equal to this. So that's it. You have then to implement get functions and compute key ID. So get function evaluates the function that's going to be run to evaluate the key, right? The compute key ID. So this is going to return this target basically. And then, whoops. And then here in the compute key ID, that's where you have to match the target with the data encryption key. And we retrieve those from our data encryption key service that I will show you in a minute. Okay, so let's get back to our schemas. So we saw now all this, in the code. And here, let's have a look to how all of this works, all the configuration and how everything works and is implemented in my project. So let's start here on the right, create the key vault and the index. So the index is actually created here in the key vault and deck setup. So here you can see just a post construct. This post construct is creating the temporary Mongo client that I mentioned at the beginning. And with this client, we can create here this setup key vault collection. This setup key vault collection, so its role is to create the key vault and then create the index. So we retrieve the key vault information. If the key vault exists, so I have a test to test if the vault exists. If it exists, then I just say it exists in the log. I'm overlogging, by the way, because it's a tutorial, but I'm putting logs everywhere just to follow what's happening. If it already exists, I'm testing if the index already exists as well. And if it does not, I create the index. Else, I can just create the collection directly with the index as well. So, and I can just do that by creating the index, because when you create an index, you create the collection along with it. And to create the index, all I do is this. So it's just with new index option, you provide an index name. It's a partial filter as well, because we only index the data encryption keys that has a key alt name, and unique true. That is the very important part. And we just say vault create index with all the options we want. So it's an ascending index on key alt names with all the options we just mentioned, partial and unique. And that's the two functions I use to detect if I already have the collection or not, and to check if the index already exists or not. Cool. So that solves this, and that. Once we have the key vault created, we can initialize this MongoDB key vault client. This is done here in the MongoDB key vault client configuration. Oh, I skipped, I think, something here. Yes, so here I'm creating as well the create or retrieve the data encryption keys. So I will come back to this in a second. Because for this, I need this first. So I mentioned that this key vault client in MongoDB, in Java, it's called the client encryption. So that's what we are initializing here. So here you see that I'm creating the Mongo client settings to create the connection string. And then I configure the client encryption settings with the key vault options. So the key vault, well, basically where the cluster is for those keys. that vault. You have the same thing here for you have the key vault namespace and the KMS provider, right? So the key management system, the one that contains the customer master keys. Then we build and we can just return the created Mongo client encryption object. So here I mentioned a few things, so let's explore a little bit. I mentioned the KMS provider, so let's see what I've done here. This is done in the KMS service implementation. And here, so I suggest you replace this in production. I have some documentation here, but again, you should use AWS, GCP, or Azure key management services to do this in production. Here, I'm just creating my local map, hash map, to create my local key management service, which is just local key and my master key. My master key that comes from my master key service, which generate a new or retrieve a master key from file. So if it's the first time you start this project, you're gonna have a newly created master key.txt file that is created for the first time, and the next time is gonna reuse the same master key. Master key, it's just binary file, so you cannot read it like this, but you can read it from the code. In the end, it's just an array of bytes, and that's, so I'm not going to explain the code, but it's very simple. You use file input stream, and you can also use next byte to generate a new master key. You can retrieve the file from file, and yeah, that's it. And save here, you do the opposite. You use the file output stream to write to the file, right? So that's all the management for the master key that I use. But again, you should replace this in a real production environment, because you don't really want to store your keys, your master key here, right along with your production code, right? Because if you have a theft, if somebody steals, all your project and all your or can access your production environment, basically they have the car and they have the keys of the car along with it. So you should store that more safely elsewhere. Cool. Let's get back now. So now we have a MongoDB Vault client. So now we can create the data encryption keys, which is done right here in this function here, right? So here I'm doing just one thing here. I'm using, as you can see, the encrypted collection configuration setup, which comes from here. And that's a very simple class I created just so we have the list of all the collections we want to encrypt in MongoDB. So here it's MyDB persons and MyDB companies. I have the class, the entity class that represent that collection, and I have the name of the data encryption key that I want to use in my configuration, in my names, right? So that's the only piece of configuration you have to touch. If you add, for example, a new entity here, let's say you want to, I don't know, manage cars, for example, well, you would just duplicate one line here and duplicate all the code here. So create a new DTO, create a new entity, create a new repository, service implementation, and a new controller, and basically that's it. That's all you have to touch. Everything else is completely dynamic. That's all the point of all this configuration. So again, here I have my list. I do for each, and for each, I'm going to create one data encryption key. So here you have the algorithm to create a key. Again, there is a verification to check if the key already exists or not. So first I'm trying to fetch that key by the alt name, and if it does not exist, then I create a new one using the client encryption that we just created before. If it does exist, then I just retrieve it and reuse it, right? That's it. Cool. Next. Well, next, but also can be in parallel. So I showed you the master key and local key management system. So this part here is already sorted to create our client. We have the data encryption keys, which is using that configuration of metadata I just showed you, which was this, right? This encrypted entity. Encrypted entity, I guess you can imagine what it is. So it's just a class It's just a POJO with these information, so nothing fancy. Okay, now we have a more complicated part of how to implement this, right? Because we have all the dependencies here sorted except the JSON code, but it's part of this. So let's see how we implement now the automated encryption client. So this is configured right here, actually, in the MongoDB secure client configuration. I was not very inspired by the naming. So let's see how this is happening. So first, you just create, the whole thing. So this is, of course, retrieving a few informations from the configuration, basically almost everything, especially this path to my crypt shared library, the automated, library that is replacing MongoCryptD. I'm retrieving all the paths for all the connection strings. I'm retrieving, well, as you can see, key vault details, etc., etc. With all this and with the dependency of the schema service and the key management service, I can create a Mongo client setting, which is just the basic connection string to the cluster that is storing the data, the encrypted data now. And I can create this Mongo client settings builder customizer. In this customizer, I need the mapping context because I need the mapping context to create the schema creator, the Mongo JSON schema creator. I don't want to explain all the code here because we are going to be there for hours, but the gist is using this schema service, I can generate my JSON schemas, so both for person entity and my company entity, and I can create a map that I can then feed to the auto encryption settings here. I can also feed extra options, which is the path to crypt shared with the required true. And I can also feed the path to store where the key vault is, right? Because it can be a different cluster. So all this is used in this auto encryption settings, which I then use to build finally the builder, right? Because it's just a builder that we're feeding here. And this customized builder will be used to create the final Mongo client in Spring Data. Because all this in the end, it's using the automated Spring Data configuration that is in the background. We are just customizing the builders and providing the things, as the automated pre-configured Mongo client from Spring Data is using, right? So we are just feeding the things we want. So with all this configuration, I can show you quickly how I generate the schemas. It's a bit complicated, but it's nothing really fancy. I'm just moving things around. But the final part is that it's right here, right? The big part is right here. We use the filter Mongo schema creator encrypted only. So basically, that means that in those two model entities, person and companies, we are so iterating through them, and we are only filtering the fields where we have @encrypted, right? So in the end, in the schema, you only have SSN and blood type, for example, for person, and for company, we only have the money field, right? But it's exactly the same thing. And then for those fields, we create a schema, we transform that to a schema document, and we transform this to a BSON document. And finally, we can use this to populate both the client-side JSON schema, the one that we use here for the Mongo encryption automatic client, and the one we use also to create the final encrypted collection in MongoDB. Cool. So I think we covered most of it now. So that's the schema, library, connection to the vault, all the configuration fed into the builder. yeah, and I think the only piece I'm missing is this create encrypted collections, which, if I'm not mistaken, is right here. So here you can see we create or update the collection because it might already exist, just like the vault may already exist if we execute this project several times. So if the collections already exist, I'm running a command, new document call mode. So I'm sending an admin command call mode with a new validator, and I'm resending this JSON schema, the one I just generated here. And if the collection does not exist, then I just create a new collection with the new JSON schema validator, right? You can see the option here, new create option, validation options, new validation option, validator, JSON schema wrapper, schema, right? So that's creating the new collection if it does not exist already, but if it does exist already, I may have changed the entities. So those, whoops, that person entity here, I may have changed, like add a new field, for example, here in my person entity. If I add a new field, I want to change the JSON schema, both in the client side and server side on the MongoDB cluster. So that's basically what's happening here. So this here is what's happening. The call mode is just changing the validator on an existing collection. Again, I have some code to test if the collection exists, etc. That's it. That's really it. That's all I have here. So I think we've been around all the code now, so I can show you how it works now for real. So let's just execute the code. And we can see all the logs. So sorry, the console is a bit small. I hope it's big enough for you to read. Well, I don't expect you to read everything, but basically you can map all those lines here to those lines here, to those to that schema here. You can remap in order more or less what's happening here. So if we take the beginning, for example, we create the MongoDB Key Vault client. We create the local key management system using the master key. We start the encryption setup. We use this URI. We create the MongoDB client instance, etc., etc. You can see here that we create the data encryption keys, one for the company and one for the person. What else is happening? We create the schema, the schema map. You can see here in action the encrypt sorry, where is it? You can see here the entity spell evaluation extension, the one that transform this into the actual company entity key, data encryption key IDs that we can use. And at the end, it generates the JSON schema like this. So this is the schema for the person entity. So you see here the encrypt metadata, the one that contains the key ID. So this key ID here, NPAC8 something, it should be exactly the same in our collection. So if I refresh here, now I should have my key vault and my two collections. If I go to my key vault, I should find my person deck and my company deck, and it was the company deck. So that's my encryption key here for my person collection, right? And oh yeah, it's base 64, so it's not the same format, but yeah, trust me, this is the same, and it works. You have the properties, so the social security number and the blood type, so with the deterministic and random algorithm. So this is the schema that we then feed to the client and the server. We have the same thing for the company entity. Here we have, again, the key ID and the only property that is encrypted in company, which is money, right? So it's long and it's a random algorithm. And we can verify this in Compass, actually. So if we go to the person collection, then we go to validation, we can see this same schema here that was created for us automatically. And same for company, validation, we can see this schema again. So of course, now my collection is empty, same for company, but I can give it a try here now. So let's give it a spin. For this, I can go to the README here at the bottom of my repository. So here you have all the information, how to get started. You have the Maven command lines to start the project. You have a command line to start a local MongoDB instance, but of course I recommend you use MongoDB Atlas. That's going to be a bit easier for you, especially if you run in production. You have the information for the MongoDB automatic encryption shared library. You click here to download it, and then you have to set the path correctly to use it. You can use Swagger as well to test everything. Swagger is already implemented in this project, so you can see my 3-person and my 2-person routes. So we could use this as well if we want, but just for simplicity here, I will use my curl commands. So if you click here, you see that I'm sending this person to the database. You can see that it's written in clear text, of course, because that's the client side. Past the driver, it should be encrypted. So now if I go to MongoDB and go see this person document, if I refresh here, you see that now I have one document created in MongoDB, John Doe, with an encrypted SSN and an encrypted blood type, right? And this underscore class that belongs to Spring Data MongoDB. Cool. Now I can try to retrieve all the persons in my collection. And I don't know if you can read this at the bottom. I'm probably maybe a little bit in the middle, hopefully not too much. But you can see here that the blood type is in clear text and the SSN is also in clear text, right? So it was able to read the document from MongoDB, decrypt it, and come back in clear text. I can also do a search by SSN directly. So here I can click here, and as you can see, I retrieve exactly the same document. Just to prove it, I can just remove one number, and I have the 404 error, the one I showed you earlier. And yeah, I could do exactly the same thing for company. I think you get the point. I can write a document, I can read a document, and it's the same thing in here. The money is encrypted, right? So it's exactly the same thing. Okay, so I think we've been around all the code. I think you saw everything. Oh, maybe I can just show you here the key vault. We can confirm again that we have our data encryption keys, one for person, one for company. And also we can check the index, and it was created here again automatically for me by the code, right? So we have our unique key alt name with unique and partial, right? And if we look at partial, this is key alt name exists true, which is what we need to be able to access those two data encryption keys. Because, well, right now I have just 2 encryption keys, but you know, in another project I could have hundreds or millions of data encryption keys, and this can be then a problem to access those keys efficiently. So, all right, I think I said everything I wanted to say. Yeah, to download the only thing I think I said but didn't show you is to download this Mongo automatic encryption shared library. So you click here on download. It's going to lead you to the MongoDB Enterprise server download. And the trick here is you just have to click here and not download the server, but you have to click on MongoCrypt shared, right? So click here, you have to select your operating system. For me, it's Debian, and you just click download it, unzip it, and then you can just set the path correctly in your MongoDB properties. So for me, it's right here, and then you can just use it. So yeah, that's it. Thank you very much. I think I said it everything. Sorry, it was a bit long, but it's a very complicated topic and a complicated video to record, to be honest, because there is really things everywhere. I hope you learned something today. If you have questions, please reach out. You can open an issue in the GitHub repository, or you can reach out directly to me. In the README, you have all my information at the bottom. I'm just going to share them for a second again. Here at the bottom, you can reach out to me directly on GitHub, or you can reach out directly to me. You can ping me. I'm at Mabolox88 on the MongoDB Developer Community Forum. I would be very happy to answer all your questions about CSFLE, Spring Data, and Spring Boot, and all this project. So yeah, enjoy. Let me know how it works for you in production. If you face any issues, if you see things you think I can improve in the code as well, I will be happy to receive your pull request in GitHub and review this with you. Thank you very much for everybody that stays until the end, and see you in the next video. Thank you. Bye-bye.